Welcome to another PAVE virtual panel. Thank you all in the audience for joining us today for our latest discussion, AVs at Work, Construction and Mining. This month, we're looking beyond the application of autonomous technology in passenger vehicles to explore other applications across the transportation space. Last week, we had a conversation on national security applications, and I'm excited today to moderate this discussion on applications within mining and construction. As a reminder, you'll be able to find the full recording of this panel, as well as our previous virtual panels, on our YouTube channel, website at pavecampaign.org, or social media at PaveCampaign. Now for some introductions. My name is Tabitha Colter, and I'm PAVE's Director of Operations and the moderator for today's panel. We have three incredible PAVE member guests this week I'd like to briefly introduce before we dive into the conversation. First, we have Bibhrajit Halder, founder and CEO at SafeAI. Bibhrajit, welcome to our discussion today.
Thank you.
Our second panelist is Angus Pacala, co-founder and CEO at Ouster. Angus, great to have you involved.
Glad to be here, thanks.
And finally, we have Ozgur Tohumcu, CEO at Oxbotica. Ozgur, good to see you today.
Thank you. Hi, everyone.
Well, thank you three for joining us at PAVE today for this conversation on autonomy, mining, and construction. Now, mining was one of the first applications of modern AV technology, with Caterpillar launching an autonomous mining truck project shortly after the DARPA Urban Challenge. Bibhrajit, you worked on that project personally. Could you help us understand where the technology was then and why that particular use case was able to become one of those first commercial projects?
Thank you. Thanks for having me, Tabitha. I think maybe just to get started, Caterpillar was actually doing mining autonomous truck back in 1995. Now, believe it or not, they actually had an autonomous truck running around in their backyard in 96. They probably realized they're a little bit ahead of the time, both from the technology and the market point of view. But they fast forward, if you like, DARPA Grand Challenge came along in 2002, 2003 timeframe, and I got involved pretty much day one. So I've been doing it for almost 18, 19 years. And DARPA Grand Challenge was super successful. As you can imagine, this has really sparked the interest. And Caterpillar was one of the company really took it. So I think about 2007, 2008, Caterpillar said, it's a go time. We can take it to production. And to your second part of the question, why? And I joined Caterpillar in 2008, literally when the starting point is that if you think about the mining, first thing it is an extremely constrained and repetitive environment. Think about a mining haul truck is doing the same thing 24/7, makes it perfect use case for autonomy. Safety is a no-brainer. If you can imagine this big truck doing 24/7 in a different condition, if you take a human out of the harm's way, safety is a no-brainer. And the third important part is the productivity, the critical part. If you can run this vehicle longer, think about autonomous truck can run like 1,000 extra hours, productivity is a no-brainer. So all those three come together, makes it a perfect use case. And I think Caterpillar did an amazing job, not just Caterpillar and Komatsu, amazing job working over 7-8 years to actually deploy it in the production. And I think just a one point on that, just to close it on, is that I think they have been running almost, I think Caterpillar recently announced about 3 billion tons of material successfully did autonomously 24/7 without a single fatal accident. That is actually a great testament for this industry and autonomous application, if you will.
Definitely. And Ozgur, could you kind of give us an overview of a typical operation design or use case for an autonomous mining truck? How far are they driving? Where are they driving? What kind of obstacles must they deal with? What makes that ODD easy, and what are some different challenges?
Yep, absolutely. And I think when we talk about it, I think we're going to see what makes it easy, makes it possible, like Bibhrajit was saying, that it's been going on for a while. And then I think what makes it challenging will also provide a lot of opportunities for new players like us. Just a few words about us and how we see the mining field. We started Oxbotica with an overall vision to build a software autonomy platform to transform pretty much all industries where people and goods move. And when you look at where this is happening, where people and goods are moving today and where autonomy is happening, this transformation is already happening in industrial settings, including mines. And it is already changing how, it's not just the transport. I expect it's going to start to change how mines are designed, built, and operated. So it's going to impact the whole value chain. With the introduction of autonomy, what we see is, obviously we're looking at the most obvious use case, again, referring to what Bibhrajit was saying, is the haulage operation. But we will see when you look at the whole value chain and how autonomy is going to transform pretty much what everything is pretty much done in a mine, all the way from extraction to take it to market. We're going to see a profound change in how the mines operate with introduction of autonomy, and that's going to create probably even like 2, 3, 4 times more opportunities than what we see today. So then I think going back to your question, like why is it happening? What's happening in the mines today, and what is a typical mine? I mean, a typical mine, and again, there are many different mines. I mean, I'll probably pick a surface mine where this is really happening at large scale. It is a very structured environment, privately owned, it's not public roads, comprised of repetitive tasks, missions. From a safety perspective, you could even argue that this boring activity for a driver with a potential to lead safety issues, I think that is another big thing for a safety case for autonomy. Wide open area roads, no 5-year-old kids running around, so it's well defined. You have vehicles, different types of vehicles, quite dynamic, and then you have obstacles, and some obstacles are there dynamically, I mean, because rocks and everything that wasn't there only 5 minutes ago. So in terms of the distances, just for everyone to envision, the load to dump distance varies, but we're probably talking like a typical trip is maybe like 10 kilometers. I mean, it depends. In big mines, you're looking at a 2-lane separated kind of highway-like structure. Like I said, vehicles and rocks are the big things that you need to be careful around. So what is challenging in an environment like this? I would say probably some specific activities like reversing, navigating into a loading dumping zone where you are much closer proximity to other vehicles. I think detecting obstacles, rocks and light vehicles, and then what the vehicle does when it actually detects those vehicles. And I think that is actually a challenge with some of the vehicle-led systems today in terms of capability wise and what we're seeing and hearing from the mine operators. And then this of course create opportunities, right? And I would like to come to that maybe later on, but how you define these systems as open architectures, interoperable, these are all creating enormous opportunities, both for the industry, also for new entrants, players like us.
Definitely. And you know, Angus, Ozgur mentioned some of those challenges, those obstacles in that domain, and you know, physical robustness seems to be one of the most unique challenges of this use case. Could you help us understand, you know, the stresses that mining trucks are subjected to and the standard of robustness they might require?
Absolutely. So we understand this pretty well as Ouster is a provider of high performance LiDAR sensors for a broad set of industries, and one of our core strategies is to build products that hit a superset of the requirements across the verticals that we serve, with mining and construction being one of multiple applications. And you know, I think people commonly think of automotive applications as some of the most stringent requirement sets for hardware in the world, but it's actually mining presents a unique and a uniquely challenging set of hardware and data reliability challenges. Unique edge cases in the environments that we operate in present challenges for the data quality and the reliability of that data, things like obscurance that you don't see as much on roads. And so, yeah, we see our mining customers have, you know, their established standards. To Bibhrajit's point, there's been safety technology in this industry for a very long time, and there are stringent standards that are far beyond what you'd see in an automotive application. So things like shock and vibration. In automotive, you might have to design for a 40G door slam test, whereas in mining, you have to design for a 100G or 200G boulder slam test, where you know there's metric tons of material slamming down into a vehicle and shocking the entire thing. So it's a more stringent version of many of the standards that maybe some of the audience would be familiar in an automotive environment. The same is true for things like temperature, you know, where mining is done above the Arctic Circle, deep underground where it can get extraordinarily cold, or in the Australian outback where the temperatures can reach above 40 centigrade. And so it really is an extreme version of the requirements that we built for, and you have to meet those requirements because that's the established precedent, and that's the reality of where the mines are. So, but then that value, by focusing and building to that requirement for Ouster, it's valuable because it then encompasses all of our other industries. Mining really is this holy grail set of requirements across robustness. And that's also true, that extends again to the data quality side of things, the reliability of the data. We can make it easier for system integrators if we can provide more reliable data in more extreme edge cases, like an incredibly dusty environment or snowy environment. There are ways to build LiDAR sensors that can pierce through dust, snow, fog better, and that's something that we have a core focus on. And those benefits then propagate into our other industries, our other verticals like automotive. So it's definitely a unique set of challenges, and it's one that we've kind of had to hit head on because, well, we have a number of active mining customers today with our sensors deployed, and we've certainly learned the hard way in some cases around how tough these environments are.
Yeah, I actually really like that point about comparing some of the automotive standards and the ones in this application. Bibhrajit, I know after you worked with Caterpillar, you went and worked on some consumer vehicle projects and then went back to mining and construction when you started SafeAI, your own company. Could you talk a little bit about that, about what led you back to that domain, and maybe expand a little bit on that idea Angus is just bringing forth for us?
Yeah, maybe continuing the kind of almost like a history. So as I was mentioning, Caterpillar started, really Google kind of started their autonomous program, actually took out some of the key players from the Caterpillar project. So Google got started, and this really kind of got started on the passenger vehicle side. Then the Ford came, everybody else came. So I spent the time at Ford and Apple. Really what happened because of the self-driving ecosystem, two things happened. Huge amount of funding got really injected into this vertical, and technology just leapfrogged. I mean, everything what we did at the first version, I call it autonomy 1.0, and then this Apple, Google are doing autonomy, call it a 2.0, is vastly different. So I spent about a couple of years at Ford and Apple. Really, the trigger point was that the passenger vehicle is so attractive. Nobody is looking into this vertical. I was like, somebody got to do it. And we come from that world. I was like, I will go back to the dirt. I can leave the Apple, Googles of the world and go back. And that's really the trigger point, right? Technology have vastly improved. The industry, this mining and construction, wanted the solution today, but nobody was really giving it. So I'm actually glad to see there are more and more people coming along, investor interested. And if you look at the technology, the biggest difference that happened is that AI is one of the critical components, right? That came and lift the algorithm to a different level. The sensors, and I think as Angus was mentioning, the better job they do, it makes our life easy. We can actually extract more information out of it. Sensor and the ecosystem got improved, and the compute platform got at a different level. So all that combination that we can solve problem now that we could not solve back in the days when I was doing autonomy in early, 2010 and 11, if you will. So that's really our biggest trigger point. And as SafeAI, what we are doing, one of the things we saw is that you want to expand that use of the technology to everybody. And part of that is that you have to be retrofitting the existing vehicle. And as Ozgur is mentioning, open and interoperable. I think those 3 points, that you are retrofitting existing vehicle, everything can be autonomous, make it open and interoperable. That will have every mining and construction company actually be able to access that technology.
Absolutely. And Ozgur, Oxbotica talks about universal autonomy, but you do focus on certain use cases, a lot of which are in this off-road, working vehicle, mining, or construction category. So how do you all look as an AV developer at balancing that core platform technology with the specialization of the different applications?
It's a great question, because it is a business, I guess, go-to-market question as well as an architectural question. And let me answer both aspects. I mean, we are not only talking about it, we are also delivering it, just to be
right.
over about it. But we are building what we call as an autonomy platform, as I was mentioning, and we fundamentally believe many of the principles of autonomy software are common regardless of which use case. And of course, there are a lot of distinct elements in each of the use cases. And just to make it, maybe just make it very concrete for everyone on the call, like we are focused on mining, and we have a number of use cases. We're addressing mining. We're starting to work with two pretty large mining companies. BP was one of the players who actually led our last Series B funding round. And with them, we are looking to deploy in refineries, solar farms, wind farms, and their airport operations. Again, I think, and then we're doing some work on last mile delivery with a grocery delivery here. And then also there's an undisclosed shuttle player we're working with. So there's an underlying autonomy platform that we work with. And there are a lot of commonalities, and there are, of course, some distinct elements. What are the commonalities? I think the common elements are some of the ones that come to my mind. The vehicles follow preset patterns, lanes and roads, pretty predictable. Vehicles don't travel randomly. They follow standard road rules and behaviors. Localization acts same on road and off road. We don't rely on specific features, road furniture or road signs. I think that is quite common in all our applications. How we work with tracking and prediction is what I would call is like more physics-based. So it's not only model-based. So these components really do not care what objects are. They're tracked just the same. And then pretty much all on-road and off-road vehicles have wheels, and they pretty much follow the same dynamics. What are the differences? I mean, clearly there are a lot of differences, like specifically in mining. Let's think about a fail-to-safe protocol, for example, just as an example, like when the vehicle needs to do an emergency stop. It's how you do that in an on-road situation is very different than in a mine. In a mine, you can probably come to a stop immediately, whereas how you deal with that in an on-road situation is very different. The object classification is different. Obviously, we need to train our systems for the specific objects that we see in a mine setting. Like if we have never seen a road grader, then we will never know what a road grader looks like. So there's a level of training that needs to be established. And then rules of the roads are also different. Like in a mining environment, the haul truck, an autonomous haul truck always takes priority over all other traffic. So I think a lot of those learnings need to be built in. So what we try to do is we basically build all the commonality across all platforms. And then we have specific implementations for these specific instances, almost as a layer, a second layer in the architecture to deal with that. So that's how we look at it.
That's great. And Angus, as you mentioned, Ouster has a number of customers you work with in mining, as well as other off-road working vehicle applications like construction. So I was hoping you could maybe talk a little bit about how working on those projects differ from those mobility-focused developers. What are some of those unique needs in terms of the hardware or the collaboration when you're looking at projects involving construction?
Yeah, well, one of the things that we try to do, and it mirrors what Ozgur was discussing about building a common foundation, that's also possible in hardware. And so we always think about building products that span a superset of the requirements across our verticals. And our major verticals are automotive, industrials, which includes mining and construction, robotics and smart infrastructure. And so we very much think about taking that platform approach of building common capabilities that can span industries. But in hardware, that means, yes, building to a superset of the requirements and the rigid specs that are written into the requirements of the requisite industries, which is kind of a unique challenge there. But I think that what we've seen, so there's mobility and then there's automotive. And mobility, I would classify as robo-taxis, maybe robo-trucking. It's a lot of startups, some extremely well-funded startups, but still there's a culture that's different from a traditional automaker, tier one, that might be developing a consumer ADAS system. And so there is a very different culture when in an interaction in working with an automaker or a traditional automotive company versus a traditional player in construction and mining. In many ways, it's quite refreshing to work with the construction and mining customers. There's more collaboration and more openness to sharing. I think partially because automotive is so competitive and cutthroat, and cost matters. Upfront cost, because it's consumer driven. You and I have to buy these cars. Every last penny is squeezed out upfront in every contract, and there's less of the, there's much more value that than just that is being built in a piece of mining machinery around what it's capable of doing, how efficiently, what its uptime is. There's just much more ways to build value, I think, in the mining construction fields. And so it's developed a little differently, and the culture is more collaborative. And then another unique thing is that the production cycles are even longer for much of this equipment and technology outside of in construction and mining than in automotive. And people always think about, automotive is this incredibly long, like slow moving industry with 5-year production cycles. We have mining customers that are concerned about having a sensor that's available for 10 years or 15 years. And they want to make sure that there's consistency of supply for the entire duration of a 15-year contract. And we're a 6-year-old company, and here we are, trying to navigate and understand how we're going to do that. But I think that our mining customers they're kind of understanding of building that relationship. They understand they need to build that relationship for a very long time and kind of bring us into the fold. And it's been fun to interact with those customers, I think. And they still have all the sophistication and stringent requirements of auto customers. And then mobility, mobility is culturally quite different. I would say all of the robotaxi companies that are more startups, it's a completely new way of taking a look at an old industry, and they're quite fast moving and willing to adopt new technology that in many cases it doesn't meet stringent certifications, because there are no stringent certifications quite yet for R&D robotaxi fleets and things like that, and shuttles. And so that's a way of testing out new capabilities and hardware or products with those customers that are receptive, that are still in an R&D mode. And so it's kind of a fundamentally different, the way they're looking at the problem is quite different in many cases than, say a Caterpillar or someone like that, that says, that knows the spec and has been working in autonomy for the past 2 decades or more. And so, yeah, it's a great dynamic to learn from each one of these customers.
Definitely. Ozgur and Bibhrajit, I saw you both nodding a lot during Angus talking. Did either of you guys have anything else you wanted to comment there?
I mean, one point, I think this is great news for Angus, right? I mean, this vertical is actually not cost sensitive at all. Like 2 things, right? They're not cost sensitive. They're not saying, I gotta take out every penny out of your sensor cost, right? Also, they are very comfortable having, a couple of them. Even if we need only 2, like put 3, just because reliability and the robustness is critical, right? If we think about a $5 million truck, haul truck, mining truck, running 24/7, hauling material, a 30-minute downtime can cover all the sensor costs, multiple times, right? So that's actually a good thing, right? You're really gonna take this sensor, putting into a real production use case, test the heck out of it, and actually use it, and not worry about the every penny. I think that's a great news. And it's as I said, I think one of the point Angus mentioned is a collaboration. I think that's really in this vertical, everybody is very collaborative, because at the end of the day, mining end user, they don't care what technology. It's like, make my truck run safely and reliably and all the time. Don't give me headache because your LiDAR, harness fall, right? So that's kind of their attitude, right? I don't need to know your LiDAR detail, just make it run. And they're willing to pay for it. I think that's I think that's a great news for people who are building, but it's a collaboration. I think that helps the overall industry, if you will.
Ozgur?
Yeah, I mean, just to add, I think a lot has been said, but I was nodding on especially the long-term aspect, and I see it as a journey that these collaborative companies are taking, because fundamentally, if you step back, and this is one of the things that excite us, I think. It is fundamentally, it is an unsolved engineering problem still. I mean, there are still big parts of it that are not unsolved. I mean, it's not perfect. Parts of it are done, but it's not perfectly done. And while we figure out who we're going to work with, or customers figure out like how they're going to work with us, I think like how you choose that partner is going to be super important, because it is a long-term engagement. I mean, we're not, even in the sensor space, I mean, Angus is not going to be able to just throw the LiDARs over the fence and they're going to be done. I think it's ever going to be evolving. So it is a journey, and it does require a collaborative mindset. Absolutely.
Yeah. That actually gets me to my next question, which is sort of, what type of advances in the technology have been the most central to expanding that off-road working AV capability, and what do you guys see coming in the future that will help drive that expansion more? Bibhrajit, you want to get us started there?
Yeah, and if you look at macro view, before even you go, like the way technology move, right? Any technology when it comes, think about internet. Internet was a hand of defense before it got expanded, right? And one of the trigger point is the quality of technology has to improve at a huge leap and bound, and the cost has to go down. So these two has to happen at the same time. And that's exactly what is happening in autonomy. Now, we talked about construction. Construction is also taking autonomy because they can afford the cost with the quality. So if you think about the technology, as I kind of mentioned, there's a 3 piece of the puzzle. Sensor is one. That's why sensor is very important, because we want all the information to come to us, and better the quality of information, easier for us. Then onboard compute platform. We want to be able to write heavy algorithm on board so that we can actually do more and more application, if you will. And the third piece is basically then the network thing comes in the picture, because you do want to back it kind of every of this vehicle have to go kind of some kind of a connection back to your cloud. So the network is another piece. You take these 3 and reduce the cost. Now you can see magic, right? And as Ozgur was mentioning, is that mining alone has so many different type of use case. If you want to cover all the use cases, you just need to have better and better and more mature in every 3 dimension in a high level.
Yeah,
Go ahead.
One of the things that I've seen that's really interesting is I think that we can learn, or other industries can learn from mining on the ODD, the operational design domain, and how well they constrain problems to actually make them tractable and get the technology out. And I've seen how customer after customer in other verticals, really robotaxi, robotrucking customers have pulled back from the idea of complete level 5 autonomy as this sci-fi concept, and it will just kind of turn the machines on and they'll know exactly what to do always forever. And they've had to incorporate this idea of an ODD into all of their use cases. And the mining has figured this out. They figured it out 10, 20 years ago that an ODD matters. John Deere figured it out in ag years and decades ago. And I really have seen basically 100% adoption of that mindset for customers. They hit a wall with the idea of level 5. And level 5, this full autonomy idea is really sexy. And it's not as sexy to have a slightly more constrained version of the technology, but it's usually a 99% as valuable version of the technology, just to have it slightly more constrained and get the technology out. So that's something that I think is really great, a great lesson to learn from mining.
Definitely.
Maybe sorry, go ahead. Just to kind of one point on that, I think that what Angus was talking about, this is really, I think if you think about robotics or autonomy in general, right, there is a phase, how do you make 20 or 30 or 100 of them run in production? There's another phase, how do you make that 100 go to 20,000, run for 10 years? I think that's something mining is ahead of everybody, right? They have the background like, okay, I can run 10 of them, but how can I run 10,000 of them over 10 years? That's a very different robotic knowledge. And I think that they are going to be always ahead before kind of self-driving kind of catches up to that. It's just kind of on top of that.
Definitely. And we are running close to time, but Ozgur, do you have any final thoughts on that same train too?
Absolutely. I mean, I think when you look at just picking up on Bibhrajit's point, I think like probably 2-3% of the vehicles now running around mines are autonomous. There's a huge potential in mining industry. If you look at all other types of vehicles that are running around, and the real value is going to be when they're all running autonomously, what type of value that creates. And that's going to be like a step change in the industry, just not looking at a simple part of the like a 10-kilometer journey, but the whole operational aspect. And then a lot of those learnings can actually be taken and applied to adjacencies, whether it's construction, like for example, as Oxbotica, we're looking at ports, which have a lot of similarities in terms of operation. So I think the big change in the industries we're going to see when you look at multiple industries, like probably driven by software and horizontal look at the problems, you're going to see less silos, more open architectures, interoperable systems. That's going to level the playground a little bit without sacrificing from safety. It's going to be, I mean, there's going to be a lot of innovation in this domain. So we're super excited to be part of it.
Yeah. Well, sadly, those 30 minutes went by really fast. We'll have to have you guys back on sometime so we can go a little further into this topic. But Bibhrajit, Ozgur, and Angus, thank you all again so much for your time to join us this afternoon, and we really appreciate it.
Thank you all.
Thank you.
Yeah, and a big thank you to our live audience and everybody who submitted questions in advance. If you want to follow up with PAVE or one of the panelists on this topic, please reach out to us via our website contact form or just reply to your registration email. And as a reminder, we will be posting the full recording of this to our website later today, or follow us on social media at PAVE Campaign to see that as soon as it's released. And please join us next Wednesday for our final AVs at Work panel for the month as we examine automation in the agriculture industry. Registration is now available on our website at pavecampaign.org/events. Thank you all.
Thank you.
Bye-bye.